So we're going to try our first problem where we're actually finding the surface area and the volume of a cone out in the world. So here we have a tent. There's a tent manufacturer trying to make some teepee style tents, and teepee style tents look like a cone. There's a circular base moving up to a vertex, as you can see in this image here. And they're testing out different kinds of tents because they want to get a lot of volume, but they want to use less material. So here's one of the options they have, and your task is to figure out what the surface area is and the volume. So if you look at this image, this 13 measures the vertex to part of that circle, and that's actually just gonna be the first part of this problem. That is the slant height. The slant height measures kind of the side of the cone, and that'll be 13. This 5 is the radius of the base, and then 12 along this dotted line, that is the height from the center of the circle to the vertex. So when we're finding the lateral surface area of the tent, just as we found in the last problem, that's going to be pi times r times that slant height. I just called it slant here. So just plug in our 5 for the radius and 13 for the slant. So we get pi times 5 times 13, and that's going to be 204.20. So that's the lateral surface area of this tent. So now for the total surface area, all we need to do is simply add on the area of the base. And remember, as we looked at in the last problem, or a few problems ago, the area of the base of a cone is a circle, it's pi r squared. So for that total surface area, we want to do pi r squared plus that lateral surface area we just found. The reason I don't put 204.20 here is, again, we want to round at the very end. So I'm just saying you're going to use the exact answer in your calculator from the lateral surface area. So pi r squared is pi times 5 squared plus that lateral surface area. Put it on your calculator, and you'll get 282.74. So that's the surface area of a cone. And now for the volume, again, it's 1/3 what the volume would be of a cylinder with the same base and height. So it's going to be 1/3 times pi r squared h, because pi r squared h is the volume of a cylinder. Plug in your numbers, we get 1/3 times pi times 5 squared times 12, and that'll equal 314.16. We can plug in right there. So in the next few problems, you're going to see there's actually a relationship with a right cone between these numbers. If you know your Pythagorean triples, if you've heard that term, that using Pythagorean theorem, those that are actually integers, you'll notice that actually 5 squared plus 12 squared equals 13 squared. So this is a right triangle. And that's not an accident, as you'll see in the next few problems. So go ahead and try those out and see how they go.